Alright guys, this is Northern Oklahoma College Math 1513 College Algebra. I'm on Chapter 2 doing Section 1. We're going to graph an equation by plotting points that go with the equation, that satisfy the equation. Alright, back in the old days, back in grade school, middle school, junior high, when you learned how to graph, we did it in a very easy manner. We just made a little XY table, and I don't know, we usually wrote the equation up here. I'm going to do something real simple for an example. Let's say x plus 2. So whatever the x happens to be, whatever x you choose, we're going to add 2 to it. So let's say I choose the x 0. I'm going to add 2 to it. 0 plus 2 is 2. So when I put in an x, I get out a y. When x is 0, y turns out to be 2. What if I put in a 1 for x? Well, I add 2 to it, and y has to be 3. What if I put in a 2 for x? Well, 2 plus 2 is 4, and so on. And you could go on like that forever. Now these turn into your ordered pairs. So you pull the ordered pairs for your equation, for your graph, right out of the table. So just think of those numbers in the table as your ordered pairs. Now let's go ahead and graph this real simple equation. So 0, 2 is my first ordered pair. So 0 means don't go left or right, just take 2 steps up, and we're right there. 1, 3 says take 1 step to the right and 3 steps up. I'm right there. And 2, 4 says take 2 steps to the right and 1, 2, 3, 4 steps up. And I'm right there. And we could have gone on and on and on. That's called a linear equation because its graph is a straight line. Alright, so you guys get the idea. That's how we used to do it back in grade school and junior high. Alright, the only thing that has changed in college is they just do their tables a little differently. I think in the book they put the x here and the y here. In the middle column they kind of used for their scratch work. So that equation that we had that said y equals x plus 2, they're going to do all their work right here in the middle. So if I picked an x of 2, here I'd go y equals, and I put the 0, I'm sorry, pick an x of 0. I'll take the x out and put in the 0. And add 2 to it, and I get my 2 for y, and so on. My 1, my scratch work would look like this. I'd take the x out, put in a 1, add the 2 to it, and get 3, and so on. Y equals, now notice I'm using parentheses. Whenever I substitute, that means when you take out the x and put in a number, I like to use parentheses as kind of a safety net. Lots of times the x that you're going to put in there, the number that you're going to put in for x is going to be a negative number. And that negative number will mess up your calculations if you don't put a parentheses around it. So as a safety net, I always start by putting parentheses around my variables, my x's or whatever I'm replacing. And so I put a parentheses around my x. I take out the x, I put in my 2. The rule said I had to add 2 to that, and I get 4. All right, that's really the only difference in college is your table looks different. All right, I want to show you another way to do your table. I really don't care which way you do your table. Here's kind of how I like to do it. I like to put my equation over here on the right. So we were doing x plus 2. I kind of like to do it this way because it keeps my x and y coordinates together. They look more like an ordered pair. So if we had the same x's and y's, 0, 1, 2, over here to do my calculations, right here, I'm working on this calculation, I would come over here, put my parentheses around the x, and I'd say, okay, I'm going to take out the x and put in 0, and then I do the math, 0 plus 2 is 2, and right there, that just kind of keeps my x and y together, and it looks more like an ordered pair. That's kind of how I do my table. So if I continue this, I would say, there's my equation. I take out my x, I put in my 1, I do the math, 1 plus 2 is 3, and there's my ordered pair, 1, 3. It just looks more logical to me. It keeps the x's and y's together. And one more time, take out the x, put in a 2, add 2 to it. When x is 2, y turns out to be 4, and 2, 4 is the point I would graph. Okay, now you know in college, they always make things more difficult. So here's that real simple equation we were dealing with. In college, they're just going to reorganize it. All right, so for example, if I move this x over here, it would become negative x plus y equals 2. I just subtracted x from both sides. This is the kind of problems they're going to throw at you, in college algebra. They're just going to have a simple graphing equation that they have messed up, and you just have to straighten it back out. So how do you straighten it back out? You have to isolate y. Okay? That just makes it easier to do your table and easier to graph. Isolate y just means get your y alone. So if I have negative x plus y equals 2, if that's the equation they give you in the book, ask yourself, how do I get that y alone? How do I isolate that y? Well, I have to make this x disappear. How do you make minus x disappear? You add x. So I add x to both sides. My x goes away on the left. My y is isolated, just like I wanted. And over here I have 2 plus x, or you could write it the other way around, x plus 2. And we're right back to our original simple equation. All right? So the first step is get the y alone, isolate the y, and then you make your table and then graph your points. All right, so let's graph this equation by plotting points. Remember the first step, isolate y. So remember, that's our first objective, get the y alone. How do I get the y alone? If we go back to, whoops, making that fence, I want to end up with y all by itself. Okay, it doesn't matter if y is alone on the left side of the fence or the right side of the fence. Y just has to be alone. So how do I get rid of the 2x? I'm going to minus 2x. Why did I do that? I just think of 2x as being a positive 2x. Think of positive as being plus. To get rid of plus 2x, you minus 2x. Remember to do it to both sides. So my 2x's are gone. My y is alone. And on the right side, I have negative 1 minus 2x. Now that's technically correct, but it's bad grammar because we like to write our x term first. So what I'm going to do instead is I'm going to write y equals, I'm going to put my 2x first, but remember it's negative, okay? Don't forget, it's okay to move that 2x, but that negative sign goes with it. So y equals negative 2x, and I'm going to put my 1 out here, but again, remember my 1 was negative. So it's okay to switch order as long as you take that sign with it. So the 1 can go to the back as long as it stays negative, and the 2x can go to the front as long as it stays negative. So here's the equation that I'm going to work a table out for and graph. All right, so I'm going to start with our equation, y equals negative 2x minus 1. We have the y isolated. I'm just going to kind of build a table around it. So that's how I like to do my tables. You can do it any way you want to. And I'm going to pick a few x's to run through. Now, 0 is always a good x to run through because it's easy to calculate. So remember, when you take an x out and put a number in, remember to put parentheses around that x. So I have negative 2. I'm taking the x out. I'm putting my 0 in, minus 1. And then I grab my calculator and do my calculations. All right. Having technical problems here. Hang on. Okay, I was having technical problems, but I think I'm okay now. So remember, put parentheses around the x because we're going to take it out and put a number in. And I'm going to choose 0 because it's easy to calculate. So I have negative 2. There's my parentheses. Take out the x, put in a 0, minus 1. Grab your calculator and do the math. Negative 2 times 0 is 0. Take away 1 is negative 1. So when I put in a 0 for x, I get a negative 1 for y. It's always good to run a couple negative numbers through and a couple positive numbers just to kind of get a good picture of the graph. I'm going to go ahead and finish my positive numbers here. So negative 2, take out the x, put in a 1. Remember to subtract 1 on the end. Do your math. Negative 2 times 1 is negative 2. Take away 1 is negative 3. Negative 2, take out the x, put in a 2. Do the math. Negative 4, take away 1 is negative 5. Now let's do the negatives. And this is why it's so important to put parentheses around the x when you deal with negatives. I'm going to do negative 2. There's my parentheses. And I want to make sure I put the negative 1 inside. Now here's why it's so important. Let me erase that real quick. Right now I have -2 times -1, which is what I want, because up here we had -2 times the x. We had -2 times the x right here. Now we want to make sure we keep it as multiplication. But if I hadn't had these parentheses right here, it would look like this. I would put my -2 here, and then I'd take my x out and put in my -1, and all of a sudden it looks like -2 minus 1, which is going to totally mess up our calculations. So always, always, always make sure that when you're getting ready to take an x out and put a number in, that's called substitution. Whenever you get ready to substitute, put those parentheses around your x to make sure that you do all your calculations correct. All right, let's go back to the math now. -2 times -1 is +2. -1 gives me a +1. And my final calculation is -2. There's my parentheses. Take out the x, put in the -2, and do the math. -2 times -2 is +4. Take away 1 is +3. Now I have my set of ordered pairs that I'm going to graph. All right, so let's do a quick graph. -2, 3. That's 2 steps to the left and 3 steps up right there. -1, 1 is 1 step to the left and 1 step up. 0, -1 says don't go left or right, just go 1 step down. 1, -3 is 1 step to the right and 3 steps down. And 2, -5 is 2 steps to the right and 5 steps down. And we have a nice, whoops, I was going to say we have a nice straight line. But you guys remember, I have a hard time drawing straight lines. So imagine in your head that that's a perfectly straight line. Okay, and for my last example, real quick, I just want to show you an x squared graph. Now the last graph we graphed was a straight line. We had a regular x in there. It wasn't being raised to a power. This one is being raised to the second power. Now anytime you do something to the x, anytime you raise it to a power, it's going to affect your graph. You're no longer a linear graph. It's no longer going to be a straight line. So we're talking about some kind of curve here. Let's see what it looks like. Now remember, I always like to pick 0 for my x because it's easy to calculate. And a good rule of thumb is to pick a couple negative numbers and a couple positive numbers. And let's work out our table and then we'll see what the graph looks like. All right, first step, put parentheses around your x. Anytime you substitute, anytime you take the x out and put a number in, use parentheses so you do your calculations correct. Especially, correctly I guess is the right English, especially when you're raising x to a power. You have to use the parentheses so that that power affects the negative correctly. Okay. So here's my parentheses. Here's my squared. Here's my +1. I take out the -2. I take out the x and put in a -2. Now I do the calculations. Make sure you check your calculations on a calculator. If I square -2, that's -2 times another -2. That's +4. +4 plus 1 is 5. Let me just show you what would have happened real quick if I hadn't used parentheses. If I had left the parentheses off and I had put this in the calculator only sees that exponent squaring the 2. So it would square the 2 and get 4, and the calculator would say that's a -4. I just squared the 2. You want to make sure you use the parentheses so that the calculator squares the negative and the 2 together. Alright, so I've written my equations. I replaced the x, I put parentheses around where the x goes. I took the x out and I'm getting ready to put in my x values. And now grab your calculator and work out all these values and pause the video for a second and see if you get the right answer. Okay, hopefully you got these calculations. Now pause the video and graph it and see if you get the right graph. And here's what your graph should look like. Notice that it is a U shape. And this is something that happens with x squared graphs. X squared graphs are U-shaped. Okay, that's it for this lesson.